Debugging microservices is hard. You got multiple services running in multiple instances, possibly even on multiple different machines. If you only rely on logs, you're gonna have a hard time. Every time you need to see what is going on, you're gonna need to aggregate those logs, filter out those logs based on a session or a timestamp, etc. That adds way too much to your everyday workflow. You should just use tracing. If you don't know what tracing is, think log messages. But instead of strings, we're logging objects, and each message has start and end properties and some arbitrary data. All messages point to a previous parent message and are connected to a session that gets created whenever an operation is triggered. For example, a place order button is clicked. And all of these messages get sent to the same server regardless of which service or application created them. So instead of this, you're going to get something that looks like this. So in this video, I want to show you how you can set up tracing in a demo application that I created for food ordering, built with React and Go. Step 1. We need to initialize Sentry's SDK in all of these services and the React application. There are instructions for every Sentry SDK, so feel free to look it up for the SDK that you're working with, but I'm working with 10-stack start in my case, so this is how I initialize it in the client.tsx file, sentry.init, and I make sure that the browser tracing integration is included. This will enable the SDK to start traces. I also want to make sure that the traces sample rate is set and the trace propagation targets point to localhost 3000. This is basically how I have my application set up. The client side is sending API requests to localhost 3000. And when we tell Sentry's SDK the trace propagation targets include localhost 3000, it's going to automatically propagate the trace in all of our API requests, but we'll see later what does that mean. Now let's go to the main.go, and this is one of the services that I have running in my backend. A very similar thing happens, sentry.init, and this is Go, it's not JavaScript, the syntax is different, but the point is the same. We initialize Sentry's SDK, we enable tracing, and I repeat the same for all of the services that I have. Step 2 is to start the trace. So we want to start a trace when an operation begins. And in this case, it is a food ordering application. There is a place order button. That's when we want to start a trace, because we want to trace or debug the whole operation starting from when the user presses the order button all the way up to the user receiving the order at their doorstep. Okay, so we are going to start when the button gets clicked. So in my index.tsx file, I have the handle submit function, and in here I'm using Sentry's SDK, sentry.startSpan, to start a span, aka we're starting a trace. It's going to be named place order, and the operation is going to be function. Now a bit below, I have place order.mutate. This is going to send an HTTP request to the backend for frontend server, the web server that serves the application. And in order to make sure that I am sending or continuing the trace that I started, I am sending the Sentry trace and the baggage. Bear in mind that in most of the cases, Sentry's SDK is going to do this automatically for you. I mean, that's exactly why we added the trace propagation targets here. But I just wanted to show you, in case it doesn't, or in case you're working with an SDK that doesn't have this capability, or you want to do it manually, this is how you can do it. You get the trace header from a span that you have started, and then you get the baggage header from the same span that you have started. These two items, the Sentry trace and the baggage, these are basically strings that keep the values of the trace of the parent span and some extra values that Sentry adds, like the environment, etc. In order for us to pick up the trace on the server side, we need to send these two, the Sentry trace and the baggage. So we can see here we are adding them to the headers and the API request gets triggered. Now going to the server side, we are extracting these to the baggage and the headers. And because we're using a BFF, a backend for frontend, we're just passing along the same requests and the same baggage and Sentry trace to the actual backend, which is built with Go and with microservices. This is an example of how you can get the trace and the baggage and just like pass it along without necessarily contributing more to this trace. Now let's see what happens on the Go side of things. If we go to the order handler here, we have the response writer and the request itself, the HTTP request that we received. And just like the place order function, literally r.header.get, extract the trace header, extract the baggage, but this time we are actually continuing the trace. So we use the sentry.continueTrace method. We pass along the Sentry trace and the baggage that we got from the headers in order to continue that trace. As we can see, we have the continuation options here, and below we start a new transaction with the name of http.server and with those continuation options. So we are looking at this moment right here. So first we created the place order in the client and we sent the request. The BFF server side didn't do anything except just passing along the trace that we already started. And now we are in this part right here where in Go, we are basically creating a new transaction with the name http.server and the description of post/orders or method/path. And we can see that here, right here. We have the method first, and then we add the path. So now we are attached to the actual trace that we started from the client side, from React, from JavaScript, but now we are on the backend in Golang, and we also have a transaction instance that we can use to start new spans. For example, in this case, the first span on Go side of things that we create is deserialize span with the description of create order requests. And what we want to do is we are wrapping the JSON new decoder.decode. We want to see how long the decoding happens. And then right after that, we are finishing this span. When we manually start spans, we want to make sure that we actually finish them. So in Go's SDK, we need to do that manually, whereas in JavaScript, we use the start span, and whenever this callback ends, this span is going to get finished or reported to Sentry automatically. In Go, we need to do that manually. Okay, moving along, we have another span or a child here, which is of type function, and it's going to be the order repo.createOrder. With this span, we are measuring how long does it take to create the order in the database. And that is this span right here. And the answer is 8.32 milliseconds. You can see that there's a child span inside of this one, which is of type DB SQL execute. And we actually created that one. So let's get into the create order in the repo and check it out. First, we can see that for the context, we are sending the create order spans context. Because we're going to be creating a child span inside of this function, we want to use this spans context as a parent. Let me show you. Order repo is here. We instantiate the parent span by using span from contexts. Using that parent span, we start a new child on it, DB SQL execute, and we pass in the query as a description right here. As I mentioned, we can always add some arbitrary data, and in this case, we're going to add the DB system of PostgreSQL. The operation is set to insert, and the DB name is set to orders because this is the order service, and the order service has its own database, so we're only inserting into that database here, and this is what we're inserting. If something happens here and we come back to check it out, these are the informations that we want to know, right? We want to know what happens, where, which table or which database did we write in, what is the query that we executed against that database, etc. So this is how we achieve that Okay, in this case, I am deferring the finishing of this span because I don't want to remember later on, so it's just easier to say defer order span dot finish. And that's why we can see this being as a child span of the function one that we created earlier. And if we look at the sidebar, first we can see the actual query, and we can also see the span specific data that we added right here. If we move along, we're going to see transaction.startChild is of type function, and it's going to be publish order created. This is a RabbitMQ message, and we're sending this message or event to notify all of the other services that the order got created. A new order got created, so if any of these services are interested to handle that message, now is the time. And this is going to be a bit different, but not so much. Let me show you. We have the queue here, and we are invoking the publish order created method. And just like the repository, we are passing the context of the span in which we want to append more child spans to, right? In this case, that is the publish order created. So if we get into the publish order created, again, we are instantiating the parent span using the span from contexts, and then we're starting a new child span with name queue.publish and operation and description of order.created. We add some arbitrary data to it, and then we use the channel to publish that message. And just like we did on the client side in React, we are appending headers to this message as well. The trace header, and we're going to use that span to obtain the Sentry trace header, and also the baggage header. Again, same span, just invoke the toBaggage method to obtain the baggage. So this way, any microservice that handles this message and looks into the headers is going to be able to extract the trace header and the baggage and continue contributing spans to the same trace that we started back in React land. Just so it's clear, this is where we are right now. queue.publish order.created. And the next one that we can see here is queue.process. This span, queue.process, this one is actually being created by a different microservice. And if we scroll down and look into the trace data, we're going to see that the service that creates this is actually the inventory service, which is not the same one that created all of these other spans. So if we go to the inventory service into the consume events, where we are setting up or registering the messages that we want to handle, we can see that we are extracting the Sentry trace and the baggage from the headers of the message that we received, create continuation options using the continue from headers, just like we did before, and then starting a new transaction. So you're kind of starting to see a pattern here. We are starting a trace in one place, and whenever we are going outside of that place, whether that's a front end or that is a backend server or that is a microservice, whenever we are sending a request or a message that takes the operation outside of it, we are taking the Sentry trace header and the baggage, and we are sending those values along with the message or requests. And since these are strings, we can keep the same trace alive as long as we can move or send these string values across. We saw that happen with a regular HTTP request, and now we're actually seeing it happen with a RabbitMQ message. Again, as long as we can send these two values, the Sentry trace and the baggage, we can extend and continue the trace and contribute to it. So yeah, if we continue implementing the instrumentation, which is a term we use for placing and creating spans, and propagating the trace by sending these two values, we get to see a really long trace that starts from the user pressing the button with the place order span and lasts when the delivery is completed. If we look at the timeline here, we get to see that the whole operation took 1.5 minutes. And since this is a demo application, of course it's going to be 1.5 minutes from placing an order to getting the delivery. In real world, this might have been a few hours, maybe even a few days if you're ordering something else. But that idle time is going to be shown either as a span or something like this, where it says no instrumentation. No instrumentation means either we didn't cover this part with a span or anything, or maybe there is no processing being done anywhere, right? But we are keeping the trace alive because we keep sending the Sentry trace and the baggage. So yeah, this is exactly how it's going to look like in real life, with the only difference of the seconds are most likely going to be minutes or hours or maybe even days. But yeah, there we go. This is how we can set up tracing in a microservices application and propagate the trace between the microservices. We also saw how we can append additional data to it, like for example, the database spans have the query that we're executing, or the queue.process has the service name, the name of the service that handles this message, or even the delivery assignment has the driver ID and the order ID that tells us who is the driver that is delivering this order in case we need to reach out to them. That's how we can set up tracing, that's how we can add additional data, and that's how we can see where the application spends the most time, whether that is a database query that is running slow, or some other part that maybe is working on filtering data or sorting data that can be optimized. If you want to check out the source code of this application, I'm going to put a link in the description below, but basically it is on nikolov/tracing demos, and that would be the Debugging Microservices demo right here. So I hope you liked this video. I'm going to see you in the next one. Thanks for watching.